So in about a month or so, we're probably going to be opening up the call for papers for DevNexus. In case you've never heard of it, DevNexus is currently the largest Java developers conference in the US, actually probably in North America. I don't think Canada does a lot with it. Java 1 has been announced. It's coming back in September, I think it is, in Las Vegas. So if you like that, it's coming around. But like I said, the call for papers is coming up soon. If you present, you get cool swag, right? You also get to come to the rest of the conference for free. And you get, of course, you get our undying love because you guys, you come to the meetings, you come to the conference. When you speak at the conference, then you share what you've learned with everybody else and it makes the whole thing better. So, okay. Any questions before we get started? No. Good. So, this is the talk. The 3 rules of TDD are useful and incomplete. I'm Burk Hufnagel. I've already introduced myself on that. I work for Doherty Business Solutions. This November will be 9 years. So before we get started, just to kind of stretch your brains a little bit, I want you to think of a solid 3D shape, like a cube or some kind of a thing that you could hold that would actually make different shadows. These particular shadows, circle and a square, that can be done. It's not hard, right? But we'll add to that, the clicker is not working nicely, the giveaway. Yeah, so if you normally think about this and you haven't seen what that thing was, the first two are kind of easy because if you take a rod and you cut it to the length of the diameter, you can hold it from one side and it looks like it's a square, but if you look on the end, then it's circular, right? But this is the way, this is the other piece. If you start from the center of the circle and you cut out to the outside edges, that's how you get this triangular shape. There's somebody online who actually makes these things. I bought one. But the cool thing about it is, depending upon your point of view, you see something completely different, right? You see these 3 different things. And lots of the things that we do have that same kind of a feel to it. When we're working with software, the way we look at it as a programmer is different from the way a user looks at it, and it's different from the way the support people look at it, right? So points of view are important, and if you can get better points of view or different points of view, sometimes you can get a feel for what the real thing is. So it's called foreshadowing. We'll use it later. Okay. So, there we go. Is this talk for you? Hopefully it is. 3 simple questions. The first is, are you interested in or are you currently practicing TDD, test-driven development? Okay. We've got a couple of hands. Good. Second question, are you willing to change how you work? And I ask this because without change, you're not, if you keep doing what you're doing, you keep getting what you're getting, right? So, and the last question is, do you really, really like manual testing? Okay, the right answers here are yes, yes, and no, right? Manual testing is a waste of time most of the time because you have to do it again and again and again and again. And it's just, yeah, so, okay. Who am I? Well, I've already told you a couple times, but I get to brag too because I'm the speaker. I've been doing this for a while. You can tell by the Sun certification there. I'm a Sun certified programmer, developer, and enterprise architect. Enterprise architect does not mean then what it means now. Now it's, a whole thing. Enterprise architect then was Java EE, Enterprise Edition, right? And being able to use that set of software and understand how to design things. I got to be a tech reviewer for this book. This originally was the Java 5 version, but the Java 6 version was based on top of that, and it's a little more recent, so I'm claiming it. And this book was written by the people who Kathy Sierra and Bert Bates. Those are the people that were actually the primary developers for the exam itself. Okay, and they gave me this wonderful quote. Right. Now, I don't know how much I actually fixed that counts, right? But it's pretty good. It's like, yeah, I'm debugging the code for the people who do the exam, Okay, like I said, I've been around for a while. 2 years ago, a year ago, I was named a Java champion. This is people who work in the Java groups and help support Java and help other people learn. And about 10 years ago, at Java 1, I got named a rock star, which means that it was one of the top 20 talks in the conference. People vote on it. I also had a wonderful opportunity. These books, 97 Things Every Person Should Know, these are open source books, essentially. The articles that we submitted these are not copyrighted. So somebody took one of these books, I think it was the architect book, and did their own version and has it out there on Amazon right now, and you can buy it. But we got to share some of what we learned and put it out there. Okay, the agenda, very, very quickly. What is TDD? What are the 3 laws of TDD? Makes sense. How are they useful? How are they incomplete? And what's the solution? What do we do about it, right? So if we've got something that's incomplete, we really want to finish it up and make it better. So, what is TDD? Well, for most people, TDD was introduced through this book by Kent Beck. Came out in 2002, 2003. What he's got here is actually based on something he'd written about earlier in his book, Extreme Programming Explained. At that time, it was called Test First. But the point is, the idea is, you're writing tests before you write the code, and that's a key piece. Sometimes the clicker doesn't work. So, in my view, and a lot of others, TDD it's a very efficient 3-step process. Okay, first, you write a failing automated test. This step is called red because when you run the test, the text prints out in red showing that you've got an error. Okay, the next step is you write just enough code to make it pass. This is called green because when it passes, everything is green. And the third step is refactoring. And refactoring is an important piece to this because refactoring is where we clean up the mess we made during the first 2 phases. It also is the point where we can go ahead and reorganize the system because we've got tests in place that act as safety nets. We can then go ahead and reorganize things, and as long as the tests still pass, we're good. We know we haven't broken anything. Right? It doesn't get a color because you're not supposed to change states in this. It should stay green the whole time. If while you make a refactoring, you change something and it breaks, it goes red, you know you got to fix that, so you undo what you did, and then go ahead and try it again. So this is the basic process for test-driven development. I say it's efficient. Part of it is because when you're doing this, you're focused on one thing at a time, right? Normally, if you're working on code, you get an idea, you've read the requirements, you say, okay, I need to do this, and you start writing some code, and an hour later you might look up and, okay, I better run the debugger, make sure it all works properly, that kind of thing. When you're writing a test like this, you're focused on one piece of it, one small piece of it, because, well, actually, at the unit test level, right, which is what most people think of with test-driven development, you're focused on one small piece, like calling one method and it does one thing, right? But you can write automated tests at any level. You can write them at the end user, at the end user level, where you automate a web page and type some data in, click some buttons, and make sure that you get the results that you're expecting. But the idea is you're working on one expected behavior. How big and wide that behavior is depends on what level of testing you're doing. And then you write just enough code to make that work. Right? So once again, you're allowed to focus, okay? And then the refactoring part, sometimes it works and sometimes it don't. Yeah, the refactoring part, right? Cleaning all up, going back and being able. So this is where we prevent entropy, code rot, right? Because you've got these things done, the code is more flexible, and so it's easier to change things than it would be if you were to just write a bunch of code and then try and modify things, because you'll see what happens when we're actually going through this. If you're normally just writing code, you don't think about how do I test it, how do I modify it, what's going to happen if something changes and we need to do things different. But when you're doing this by writing tests first, it helps you think about the future and plan for things that could happen, right? You're not going to go crazy about like, oh, I need to have an interface to this even though I've only got one implementation, right? No. Do it when you need it, and that's why the tests are there. Because the tests are there, and you can make changes and see that you didn't break anything, you've got that flexibility to do those. Okay, anybody know what this means? Ken Stoffel? There ain't no such thing as a free lunch, yes. And it's in red here because this is a downside, right? Whenever you change something, it's not easy, right? If you've ever tried picking up a new skill, playing a guitar or deciding to go exercise, right? It's hard to change your old habits. So that's part of what's going on here. With TDD, it does take some time to get good at it. And what's going to happen is when you first start, your performance is going to drop because you're breaking your old habit and you're starting a new habit. You're not too sure how that works. And so that means that initially, you're not going to produce as much stuff as you do right now. And it's going to look not good, right? But as you get better, as you practice more with it, your performance will go up. And what companies have seen is not only does your performance, okay, so by performance we talk about a couple things. How many bugs do you produce? How quickly do you fix them? Right? How many get out to production? Those all go in different directions, but in a good direction, right? So you produce fewer bugs to start with. The ones that get off of your machine and over to QA or to production are less than that. And then when something does show up, you've got opportunities to make it, well, it's easier to fix things generally because with those tests in place, you may have heard people talk about this. They talk about TDD as being like double-entry bookkeeping, right? It's become kind of a popular way of thinking about it. Actually, it's better than double-entry bookkeeping. With double-entry bookkeeping, you have assets and debits, or I forget the other term for it. Liabilities, thank you. And your assets and your liabilities have to add up, otherwise you know there's a problem. So, but if they don't match up, you don't know where the problem is, right? With test-driven development, with all these automated tests, if something breaks, you know where it broke. So you don't have to go looking. You've got something that tells you, hey, this was supposed to be 7 and it's 3. What's going on? And it fails. And so you've got a place right there to know where's the problem, and you know when it's fixed. Okay, so good stuff. Yeah, so naturally happening when you try to do something new. Performance over time, we're good. Nice. Okay, so on to the 3 laws. You may have heard of a guy called Uncle Bob, or Robert C. Martin. Uncle Bob came up with the 3 laws of test-driven development and published them somewhere around October 2005. And when the 3 laws came out, I'd been trying to learn test-driven development for a while, and it was kind of, but I saw those, and I went, oh, this helps. And a lot of people find that the 3 laws actually make it much easier to do test-driven development, which is why I want to show these to you and talk about this. So the first step is you're only allowed to write production code when a test fails due to lack of that code. Originally, he said you can only write production code when you've got a failing test, right? Which means you have to do the testing stuff first. The second part is you write just enough code to fail and not compiling counts as failing. Now, back in 2005, that worked pretty well. But now we've got IDEs that as soon as you type in a class name that doesn't exist, it goes red and it tells you, or a method name that it doesn't recognize, it tells you. You don't have to wait to compile, which is good because if you're using other languages like JavaScript or something else that doesn't need a compile step, this doesn't work for you. So basically, you can only write enough test code for it to fail, however that gets detected. Right? And the third step is you write just enough production code to make the failing test pass. Okay, and this is really cool because, well, as he put it, it sort of locks you into a 30-second feedback loop. Okay, feedback is critical for us because that's how we know if we're doing things right. You know, if you've ever tried to teach somebody how to drive, or if you remember, because it hasn't been that long, when you first start driving, you kind of go off and then make a sharp turn because you realize you're going off the lane, you're going off the lane, you're going off the lane. And it's a very bumpy kind of an experience. Sort of like going to Six Flags and doing that car ride they have there. But as you practice, you get smoother and smoother, and after a while, you're just going. And you're making all these little tiny adjustments all the time, and you don't realize it because it's become a habit. TDD becomes like that. You're making smaller and smaller changes, and the good thing about the TDD stuff, though, as well, is if you make a change and it breaks, and you don't know why, you hit Control-Z a few times, right, undo, and with a couple of character strokes, you're back to working code. The other nice thing he points out is if your whole team is doing this, a minute ago, everybody's code worked. Everybody on your team, their code work, if the boss came and said, we have to ship whatever we've got, okay, you can ship it and know that all the stuff that's there does not break as long as you're only executing the stuff that we actually got completed, right? So it was a game changer for me. It made it much easier to both do it myself and help other people learn test-driven development. So those are the 3 laws. They're really cool, right? We talked about some where they're useful. Changing perspective here. When you're writing the test code, right, you're looking at it as an end user does. Right? When I say end user, I don't necessarily mean a non-programming person. The end user could be somebody who is using a component you wrote, somebody who's calling the API that you're just producing. Right? Those are end users. So when you're writing a test, you're writing it from their perspective because you're looking at it saying, okay, what is this supposed to do? What parameters am I going to pass into it? What name should the method be? Right? And so you wind up actually producing a better API than you would if you were just like typing it out because you're in flow and you're just spitting out code, right? So bouncing back and forth, you get a better API, and then when you look at the internal stuff, you're like, okay, I've got these pieces, what do I need to do? And you can focus on that, and then you can, right? So it keeps your brain engaged. You never get into a phase of where, I look up and it's 4 hours later, right? What did I do? Well, okay, I've got some code and it looks like it might work, right? Because you're doing this, you're constantly making sure, is it right? Is it right? Is it doing what it's supposed to do? Am I on, right? And so you make all those little changes. Okay, the fast feedback loop we talked about, better API design, and also, it keeps you remembering, oh yeah, I'm not doing the old way, I'm doing this test-driven stuff. Just as with exercise, if you can find a partner and pair program with somebody doing this, it works really well because when you kind of get lazy and want to just do some more because I know how to do this part, they're like, no, wait, remember we're supposed to do just enough. And it's kind of like learning a martial art. With martial arts, with a lot of them, it's all based on you need to be exactly the way that it's taught. And you do it exactly the way that it's taught, right? It's like when you put out your arm, it's got to be here, not here, not here, and they'll move your arm just a little bit right there. Oh, no, this way. Okay, yeah, like that. And you practice that until it becomes muscle memory. But then later on, they'll tell you, okay, now you need to figure out when you're attacked, not to do this all the time because somebody may not be there. They may be doing something different. You have to be able to adjust. And by first learning the strict way of doing TDD, you can then loosen up and still get the benefits without going crazy. If you've got questions, go ahead and ask. Okay. So, why are they incomplete? Okay, so we talked about the 3 steps of TDD. You just saw the 3 laws. So, did anybody see a hole? Yeah. Okay. What are we missing? Yes, exactly. Refactoring. The 3 laws don't say anything about refactoring, right? And when you have something called the 3 laws, you expect that would be this is it. If you do the laws, then you should be good. Did you have a statement or something? Yes? I'm sorry, I didn't hear that last part. What?
So, like, when you have one test case.
You have a test case, yes?
Yeah, you have you still have a lot of information.
Yes? Yes, oh sure. Yeah, but my question is, you've seen what the 3 parts of TDD are, red, green, refactor. We've gone through the 3 laws. The part that's nothing in the 3 laws is refactoring. Refactoring is not covered at all. I did a version of this talk a year ago for a conference in Brazil. And since that time, Uncle Bob actually put out another book around November. And he's got a section talking about the 3 rules, the 3 laws. And about 10 pages after, he tells you that there's a 4th law. And the 4th law is refactor. So it's a coincidence, but I'm going to claim maybe. Yeah, and the other piece is that there's two big questions people keep asking, and they were my questions when I first started too. How do I know what test to write? The 3 laws don't help you with that. And how do I know when I'm done? Right? And the 3 laws don't help you with that either. So I think if you're going to call something the 3 laws, it should cover the whole thing, right? Maybe you can't do it in 3. That's okay. But those are 2 of the pieces that are hard. And when I was first learning this stuff, actually, I posted, once again showing my age, I posted to an electronic bulletin board a question saying, hey, this stuff looks good, but how do I know what to test right? How do I know when I'm done? And the answer I got back was, if you don't know what test to write, you don't know what code to write. And I went, well, that helps. But, you know, the funny part is, about 6 months ago, I went, of course, if you don't know what test to write, you don't know what code to write, because, right, how do you know? How do you know what they are? We'll get into that. But it was a great revelation. So the solution. We want to leverage our skills, right? We're good at writing code. We should do more of that. Test-driven development says write more code. I like it. Let the computer do the grunt work. That's another thing, right? Most of what we do is automating other people's manual tasks, right? Particularly if they're detail-oriented and repetitive tasks. And that really describes most manual testing. It's detail-oriented and manual, and it's slow, and, you know, let the computer do all that stuff. Stop writing tests. Yeah, this seems a little, but one of the problems most people have with test-driven development is writing tests. How do you write a test for something that doesn't exist? You can't test something that doesn't exist, right? It's true. Although I recently had a thought about this. So we spend 12 years, if you go to college, 16 years in school taking tests, right? And no teacher has ever, on day 1, given you the test saying, okay, here's the final exam. Go ahead and do it. No. But if you're a teacher, it makes sense to write the tests up ahead of time and say, okay, now I need to make sure I teach the people how they can do this and do this. They can do the addition, teach them subtraction, teach them. And we are the teachers. We are not the students. We're teaching the computer how to do something, right? That's what code is. It's instructions to the computer. Here's how to do whatever. So of course it would make sense to write the test first, because that way we know that when we tell the computer what to do, we're telling it to do the right thing, and we haven't missed anything, right? So we stop writing tests, but you got to have a name for it. So I say write specifications and run tests. Specifications are a description of something that doesn't exist yet, right? You specify, I need a lobby that's big enough for 200 people because we're going to have all this going on, or, right? So specifications are the key for this. And some of this, people will say, this is semantics, it's words, right? The thing is, our brains run off of words. And so, and it goes back to a perspective thing too. If you think about it from the point of view of a specification, okay, I need to describe what it's supposed to do, not how it does it, but what it's supposed to do, then it makes sense to write a specification up front. And if you can then tie that somehow to some code and run it as a test, so much the better. So that's what's going on here. Specifications are based on requirements, right? The requirement says, you know, do this, so you write a specification that says it must do X. They describe what should happen, right? Which means you're explaining something to somebody, and they have to understand it. And this is another issue that we have, right? Our end users have an idea of what they want, and they're trying to tell us what they want, and sometimes they write a 20-page document for it, and sometimes they just give you a couple of scribbles and say, well, I want it to do this, right? So it's hard to get the description across, but if you can get a good description that multiple people can agree to, then you can say, okay, you've agreed that this is what it's supposed to do, I've agreed I'm going to do it, the tester agrees, and that I've done it, right? We all have the same understanding of what's supposed to happen. So specifications help with that, right? Which means you can't guess. If the specs aren't clear, you've got to go back and say, what do you mean by this, right? Or if you find a hole, right? I worked for a company, and we were going to rewrite one of the big credit companies' process for how they figure out what your credit score is. And they gave us this big stack of paperwork. It was about this thick, of their specifications. And I would be reading through this stuff, and it's like, okay, and I'd go into the meeting and say, okay, what happens about this? There's nothing in here about that. Oh, well, that should never happen. Okay. So I got that a few times. I finally said, all right, so if it should never happen, we don't have to worry about it, right? Oh, no. Okay, so there is something that needs to be done there. They just didn't really want to deal with it because, it was weird. But so no guessing. And this is another cool piece. This is what lets you separate your design from your implementation, right? If you're doing object-oriented programming, they keep telling us, right? Separate the implementation from the design. Why? Because you can change your implementation and it'll still work. Right? And we'll see some of that later. Yeah, we don't want to stop here though. So this is the specification. Now we want to talk about an executable specification. Right? And this is the part where you take your specification and you pair it up with some code and run it. So once again, we look at something from two different ways. Look at it one way, it's a spec. Look at it another way, and it's a test. Right? This is the gold mine for me. Because when you do this, you get all the benefits without having to do a lot of, I don't have to sit down and write a separate document, right? It helps me, it helps the developers that follow me, and it helps the customers. So we want to add code so that it runs like a test. Generate living docs. If you've heard the term living documents, what that means is if you ever joined a project and you say, so where are the specs on this? Where are the requirements? You say, oh, yeah, they wrote a paper like 2 years ago, but it hasn't been updated. Okay, well, that's useless. Right? You've got some idea, but who knows what's happened since then. Living documents are always up to date. And the way we do this, they work for both the business people and for your technical folks, so the other people on your team. And once again, bridging that gap between designing and implementing. So, these are my rules for TDD. Write just enough of the spec to fail, and not running counts as failing. Write just enough production code so that the spec runs. And when it fails for the expected reason, right, so it's not just failing anymore, but it's failing because the spec says it should do X and it's not doing X, right? Then you write the production code to make it pass. And then you refactor it all. Clean it all up, make sure it's clean and easy to maintain. I have a button that says, write your code as if whoever maintains it is a homicidal maniac who knows where you live. And I got that many years ago, and I've seen it as a poster. Somebody's got the quote. I don't know who it came from. But the idea is you want to write code so that anybody can pick it up and use it. And they don't have to try and guess. They don't have to try and step through it with the debugger to try and figure out, because it's amazing code. It's really complex. It does all sorts of cool things. No. You want something that's easy for people to read and easy to change, because invariably code that's difficult to write doesn't get maintained. And eventually it's thrown away and replaced by somebody else. It's like, yeah, it's just gotten too tough. We're going to have to rewrite it from scratch. Right? But if you make it easy to read and maintain, it can be reused. And people you're not, that's the other piece. If you're the only one who understands the code, you can't go and work on anything else. Right? If that section is critical for the business, guess what? You have a job for life, but you're going to be awfully bored. Okay. So there was a gap there. Because this doesn't answer the question, how do I know what test to write? How do I know when I'm done? What answers it is the zeroth. This is sort of like the 3 laws of robotics. There's the zeroth law. Yeah, this is the zeroth law for TDD. You only write a specification when you have an unmet requirement, because this is really requirement-driven development, which is what all of our stuff should be anyway, right? We're writing code because there's requirements that aren't met. Well, why not use those requirements to drive the specifications which turn into tests that prove that the code work? So I don't know if RDD is a good idea or not, but I like it. So here's the example. We're going to TDD a stack. And I picked a stack because it's simple, but it's not too simple. And it's something we can get through pretty quick. So assuming everybody here knows what a stack is, right? If you have some books on a table, you take off the top, you put on the top, and so the order is first down is the last one off, right? So we get our requirements for the business. They want push, pop, is empty, and peek. And their peek is, okay. But these are traditional methods for a stack. Right? Push and pop definitely. Is empty is a nice to have. You don't have to have that because, if you pop and it's empty, you throw an exception. But then you have to have exception handling, and Java exception handling is a lot slower than normal code. So let's have an isEmpty method, perhaps. Okay, so the business prioritized it in this order based on their expected value, right? So dev team takes a look at it and goes, okay, we look at the requirements, and they say, okay, well, first off, there's nothing in there about a maximum size. Is that a mistake? Do they not care what the maximum size is? Just want to go until memory's full? We should ask them, so we'll deal with that. Now, here's another problem. How do you test push unless you've got pop or peek already working? You push, did it actually store it? I don't know. Unless I could make some changes and let you look inside and see what's going on. We don't want that because you do that and now your implementation is leaking out to the rest of the world. So we're going to say, we're going to have to do peek, we're going to have to do push after we've done pop or after we've done peek. Push and pop are critical. Peek and is, those two can be added later. So for a minimum viable product, really we just need push and pop. So we're going to recommend that. So there's where we're handing back to the business guys saying this is what we want to do. We're going to do pop first, then we're going to do push, and later we can add the other functions if you want them. They say okay, so here's our first scenario. And as you can see, this is just a description. Given a new stack, right? Calling pop should throw an empty stack exception, pushing a value, right? And we'll go ahead and do these, starting with the first one. So this is a specification. You can tell because it extends specification, right? This is actually the Spock testing framework. It's written in a language called Groovy. Groovy is a dynamic language that's built specifically for Java programmers. The guy who wrote this saw all the cool things that other programming languages were able to do and went, I want to do that with Java. And so Groovy understands Java syntax. You can paste Java code right into it. There's a few things here that you might notice a little bit different. So def says we're defining something. In this case, we're defining defining a class, and the class name happens to be a string, which is kind of cool, right? So you can actually write it out and have somebody be able to read that and go, I know what that means, right? As opposed to test one. Right? Now we have these three given, when, then. These are labels. Normally we only use labels for a labeled break, which means we don't really use them, right? But so they're labels followed by a string. The Spock framework takes these and says, okay, anything between a label and the next label is part of a code block. Okay, you can't see it, but there's essentially brackets around that, just like for an if statement or for an else. And these are your three main pieces for a test, right? There's arrange, act, assert is one of the ways people talk about it. So given, when, then, right? If you've heard that, usually you'll hear that for like a user story, right? Well, for us, given a new instance, when pop is called, it should throw an exception, right? So that's the spec. And we can actually, this is essentially a unit test. And if you use JUnit and you just create a method there, right? What happens when you run it and you don't have anything in it? It passes, right? Well, this passes. And it generates this. So we have, right, there's the stack spec, that's the name of our class. We've got a summary. This is a list overall of what happened. Right now there's only one, but there will be under features, every one of the methods that gets run will be listed here. That's a link to the next piece. This return will actually take you back to the top, so if you've got a bunch, right? So like I said, this is a web page. And now this is all very familiar. That's the class name, and those are the given, when, then with the strings after them, right? You could show this to a business person and say, is that what it's supposed to do? And they can go, yeah. Or, no, wait, we don't want to call it pop. We want to call it mom. I don't know, right? But you can post this someplace. So when you run your tests and it generates this web page for you, you can post this, and you don't necessarily have to tell the business guys what the status is because they can see, oh, that's passing. This one's busted, and they get a better idea as to how things are going. So that's generated from this, which means it's living documentation. If I change any of those statements, it's going to change what gets produced the next time I run it. So we start with our 3 steps of test-driven development. We're going to create a new stack. So we're defining again. You can put the variable type there if you want to. You don't have to. But so we're going to create this in stack. Okay, stack's in red because stack doesn't exist. So we'll do just the minimum and we'll create the class. Right? At that point, the compiler is happy, the IDE is happy and says, oh, I found stack. Okay, good. You can keep going. So now we'll call pop. We have to create a pop. You notice pop is a void. I don't know what the return type is just yet because, we haven't done anything yet. So I don't know if I've pushed. So we're just going to return a void and that works. Okay, then we want to throw an empty stack exception. So this thrown keyword here, this is nice. If you've ever had to do something where you're checking a test, checking for an exception being thrown in JUnit, right? You have to do a try catch block, and after you make the call, you say fail, and then in the catch you can write a comment saying this is actually a good thing or something like that, so people know. Because normally try catch blocks, it's bad if you catch an error. But this just says I expect that an empty stack exception will be thrown. It's readable. It makes sense. You read that and you go, oh, okay, I get it. So when we run it, it fails because it didn't throw the exception. So we'll put in the throw new empty stack exception, and everything passes. Yay! So what happens after everything passes? We refactor. Right? We've got our passing test. So we look at it and we go, well, the methods seem to make sense. There's no duplication really. It's good. We could actually check this in now because we have working code. Right? So you could actually check this into your code repository and not worry about blowing up anything. Okay, so that's done. Number 2, we're going to push a value and call pop, and then we should get it back. And if we call it again, we should get an empty stack exception. Okay, so we're building on what we had, right? So each scenario builds on the next. Same idea, we set up the different pieces. This expect block is a combination of a when and then. So we're going to call something and check a value in here. You could just say given and expect, but it reads kind of funny. And then there's an and block, and an and block just extends whatever the block previously was. So if you said given this and you call push into for an instance and it's Tuesday or whatever, it's all still part of the given block essentially. If you do that with a when or a then, that's all that. The other thing about a then block is, and you'll see this later, in a then block, this is where we're doing our assertions. You do not have to say assert this. Any Boolean expression, if it evaluates a true, passes. If it evaluates a false, it fails. Right? So you could say, then x equals 5. Okay. I expect x to equal 5. And if it doesn't, it fails. Right? So it's a nice thing. Okay, so we've got this. So the stack works. We're going to call push. We don't have a push, so we have to create push. You notice it's empty, but it makes the compiler happy, so we keep going. We're going to call pop and make sure it equals 5. This is the assertion piece, right? If it's not 5 at this point, it's going to say that this test failed. We call pop a second time, and we expect it to throw the empty stack exception. Well, it fails. Right? We expected that. Okay, so where? Well, only if we ran it. So we're putting in code, and nothing is complaining here, so there's no reason to run it just yet. You could stop right there and say, okay, let's check the assertion, and that would be fine. We'd still get to the same place. It'd just be a slightly different route. Actually, that's a very good idea.
Are we violating one of the commandments by testing two
Which
things?
one? What two things?
We're testing that the first pop returns 5 and that the second one throws. So isn't that heresy TDD?
Okay. Yeah, there are some people who believe that a test should only have one assert, right? So if I fill out a form and I've got my name and my address and all that stuff, and I push submit, then I have to write a separate test for make sure the first name is there, make sure the last name is there, right? That's crazy. I mean, you can, right? But is there any value in it? Because your second test is going to have to say, okay, assume the first name is correct, because you can't check it, because that was the first test. And if you check it, then you can't write any more of that test, right? So it's not practical. And one of the things so it's a, should my arm be here, should it be here, right? You could do it that way, but for a test like this, I don't know how you would be able to check your second one, right? So we do this, we could do the push, and you got to get that on there somehow. And the way to get the 5 in there makes sense to call the push, and then calling pop to make sure it actually returned a 5 because So okay, so we do that, and we get the failure, and this is cool because here and this is also, it'll appear on your console if you just run it. But you can see here, it tells you it failed with this exception. I called pop. Actually, I put the work in to give us some nice things. The green up there means that it passed. The red means that it failed. Right? Here's the line that failed. Stack.pop is equal to 5. It tells you what the expected value was. It tells you what the actual value was. Right? And then you get a stack trace. But you notice here, com.grokspock.dev nexus com.grok. So there's none of the noise that's in a normal stack trace, right? Because this didn't just call this here. There's other stuff in between where the test was doing something, but it doesn't show that. It gives you a filtered stack trace, so because you can't do anything about the in-between stuff, right? You care about, well, I was calling this, and this is what happened, and there's the failure. This is a useful enough trait. They actually backported that into the language, into the Groovy language itself. It was originally just part of Spock. But you can see what's going on. So once again, the business guys can look and go, oh, we're having an issue with this. I see. I don't have to bother the programmer. They're busy. Okay. So there's our problem. So we need to fix that. So first we have to have pop actually return a value. Then we also have to have push do something with it, right? So when push gets called, it's got to store that value. So we'll put it into a local variable, or a classical variable. And we're all set up. So that should work, right? So we're storing the value. At pop, we're returning the value. This should go. And, no. Right. We got stack trace because the second one, right, because it's got 5 there, it returned it, but it didn't take it off the stack. So now we got to fix that. So actually we have 2 tests that failed because the first one, where it throws the exception, is just going to return null instead of throwing an exception. So we need to fix pop. So we'll set it up so that if the value is null, we'll throw the exception. And then we'll go ahead and temporarily, we'll create the temporary value for value, set value to null, right? So that should all work. And when we run it, everybody's happy. Okay. So refactor time comes. Right, not a lot of duplicate code. It still looks reasonable, so we move on. We've got two pieces working, so we go for the third one, pushing 2 values. This is when the stack actually has to start acting like a stack. Right now, we don't know what had happened. So we write our code, the new stack works, we'll push 2 values, we're going to call pop, and then we're going to compare that return value and make sure that it's correct. All this goes because there's no new methods that were needed, so we can then go ahead and run it. And of course it fails. So now we need to actually handle more than one value. So simplest thing to do is take an array and, which one failed?
That one should work with that implementation, right?
This implementation? Has one value. So when you store 20.
Again, it doesn't matter, right? It shouldn't fail until I try to get it to 42.
No. So pop is called it for 26. Yeah. So the second test would fail.
When you
try to pop the second one, it'll fail. Yeah.
This test would work. Because I'm just looking at the 23, right?
Yeah. What do we get?
Are you running
stack
right
pop
now,
stack trace calling pop should return 32.
You're checking both the values.
That was okay. Yeah. Yep. There's an edit. So you can see this was in the previous version. I was pushing 2 and 3 instead of bigger numbers, and it was checking both of them. Yeah. Okay. So I let my code get out of sync. Good catch. But yeah. So really, what should have been there is we should do 2 pops and check the values in order. Is what should have been in there. Okay. But we know we need the multiple values, so we go ahead and change our value into a list, and then make the rest of it work with the list. So we're going to, there we go. So we'll add the value to it, and then here for the stack, we're going to remove it. So we take whatever the size is minus 1, which would be the index for the last current value. And eventually, that gets down to 0, so the isEmpty is true, and it throws the exception. So when we run that, it's clean. So refactoring, yep. So this was value, and since it's a list now, it really should say values. So then we have to change all those to values, and then we don't need the this here anymore because it was value, and then value was in there twice, so we had to say this value is equal to the local value. I don't really understand that particular pattern, but it seems to be very common, so it forces you to have to put in that extra this on things. But yeah, so we'll fix that. And when we run it, everything works. Yay! There's the old one, 3 and 2. So all of that passes. And now I want to show you this. This at narrative, this is a groovy thing. This triple quotes says that this is a formatted string and not to get rid of the breaks. And the cool part about that is if you put this narrative up here, when you run the program, it shows up here. So you can put in text at the beginning to give people an introduction to whatever it is, whatever you need to say before you actually get to, here's all the specifications, right? So we've created executable specifications. The documents update themselves as they go. One of the nice things about this is if you're using something like JUnit or something that doesn't have labels like this, you use comments, right? But most text editors now gray out the comments so you don't pay attention to them as much, right? Because the comments aren't usable, they're not valuable. Because it's here like a string, it looks like part of the code, so when you read it, as opposed to just kind of skipping over the commented stuff, right? So this pattern, because we've got a description, a specification, if you want to call it that, and then the implementation of that specification right below it, right? It lets your brain look at that and go, yes, that does what it's supposed to do. This is where I was talking about the double entry bookkeeping, right? If this test fails and I look at this, I can go, okay, we call push 5 on a new instance, and I don't have something here that creates a new instance and pushes 5. I know the problem is right there. The code has got a problem. If the description is no longer correct, right? If I go look at that and I go, well, it says if we push 5, wait a minute, we're not supposed to call it pushing, we're supposed to call it mom, right? Or whatever the new method name is. I know that the code is out of sync with the specification. The specification's wrong, okay? If these two are correct, then I'm pretty sure it's the implementation that's got the problem, right? So because I've got 3 points to triangulate off of, I can find where the problem is much quicker. So there's the text, right, the narrative text. Common concerns, right? This is one of the most common things I hear. If I write automated tests and I have to change the code, now I got to change the test too. Okay, let's take a look at that. Here's our stack, right? We're going to change it. You can't use a list anymore. Got to use an array. Well, okay. We had to do something about size. They never did tell us about that, so we're just going to make it big. But now we have to have a separate count for the values. We're changing all the places. Every one of these methods got changed. What happens when I run the tests? Well, they all pass. But I just changed I changed like every single method got changed. What's going on here? The test doesn't care about the implementation, right? We're testing the behavior, the what, not the how, okay? And the other piece that goes with this is, let's suppose you're changing a system and you have to make big changes in it, okay? And you do have to change the test code. Okay, well, if I change the test code and I make sure that the specifications are correct, that it's doing what the business says it's supposed to do, I've got that to use as a judge when I'm writing my test code to make sure it falls in line. And when those things are in place and I run my code and it breaks, I know the problem's in the code, in the production code, right? And then fix it. So that's even though, yes, I have to make a change there, I have extra help making sure that the production code is correct when we've made this huge, massive change. Yeah. So when I first started doing this kind of stuff, I was working for a local company that does home improvement stuff. And we had a project. They wanted it done in 6 months. They had done a similar project last year that took the team a year. We had 2 people, and they wanted to do test-driven development on it because that's what the VP had ordered. And they had heard things go faster and quicker and all that good stuff. So about 2 weeks into it, we had a new person join. And by new, I mean this guy was a new programmer. He had been working in customer service, I believe, previously. Didn't really know anything about professional programming. You know, he understood the language and stuff. So as it turned out, we had recently realized that for what we were doing, we'd been using a floating point, and floating point doesn't have the precision we need. So we were going to switch to big decimal, right? And this is for something that's used basically throughout the whole application. And when the guy started, I said, I got an idea. So I brought him over. I said, okay, here's the application. I gave him a quick rundown on what it's supposed to do. Right? And I said, what we need to do is we need to change this data type from floating point to big decimal. I'll show you how to do that. And I showed him how to create a big decimal. I said, okay, well, I'm sorry. First, I showed him the tests. We ran all the tests. Everything came up green. Cool. So then I showed him how to change this. We ran the test. Breaks all over the place, right? I showed him how to go, okay, to take the first one, go to this line, right, because it tells you it's dying here, changes floating point to big decimal. 40 minutes later, he had changed all the code and everything was running. He had no idea what the application did. He had no idea what we were thinking when we wrote it, but he was able to make all those changes in a fairly complex system in a short period of time, and everything worked. That told me that there's something really good here. Okay, so that's the story on that. Recommended reading. Most people are not starting greenfield projects, so this is a very important book. Michael Feathers wrote this, gosh, I don't know how long ago, but it's still very good. Basically, I liken it to, if you have to go into an abandoned coal mine and do some work, you want to put up structures to make sure it doesn't collapse on you while you're working on things, right? This shows you how to build those structures. On the other side, you have this book, which is fairly recent, Growing Object-Oriented Software Guided by Tests. This shows you how to do TD from the start. And it walks you through a sniper program for an auction house. So it shows, starting from the very beginning, how to write the specifications, what kind of tests to write, all that kind of stuff. It's a very good book. And so Clean Code, if you haven't read it, you should. Robert C. Martin, Uncle Bob is a wealth of useful information. This is code. Specification by example goes more into the BDD style of thing. Behavior-driven development was developed by Dan North because he got tired of trying to teach people how to do test-driven development because they kept getting stuck on tests. And he said, focus on the behavior. And that's what we just did with that test there, by the way. The stack, we focused on the behavior. So that's all of it. And if you got any questions or contact information, you can get in touch with me there at doherty.com. And that's it. So, any questions? Or either I was really, really good, or you guys are going into coma from the pizza. Or both, yeah. No questions? Okay. Oh, yes.
So going back to the legacy code.
Yes.
So what if that legacy code didn't have tests and you need to refactor and then come to the new one? Would you rewrite the new test to make sure there is all good code coverage, or how would you approach this problem?
So if you're dealing with legacy code and you want to refactor it to do something different or to clean things up some, so that's that whole working effectively with legacy code. That's a good book for it. Basically, what you can do, and and this works So there's another thing called defect-driven testing. If you've got a legacy system and you have a bug, okay, find the bug, figure out what the problem is, write a test that fails because the bug is there, fix it, make sure the test passes, check in the code and the fix. Okay? Similar to that, for your refactoring, you need to look at the code that you've got, figure out what it's supposed to do as best you can, right? Put some tests in there, maybe tweak the code, see if it breaks because, okay, I've made this change. Is my test actually recording this? And then you can start doing some of the refactoring. Some of the built-in refactoring tools in IDEs can make it simpler because they can look at it and go, I can't do this. And then you know it's really kind of ugly and you don't necessarily want to take that chance. But yeah, it's trying to refactor something that doesn't have tests on it is iffy at best. Yeah.
The technique I use.
I
actually recently read most of Feather's books. I got distracted and didn't finish it. Is start. This is for the recording. I start writing tests with a code coverage tool. So I write a test. I see, basically I call the method, see what happens. There's a passing test, and I see what was covered. And then I write another test where I change the input parameters to make it force a different path until I get coverage that I'm comfortable with. And there, that's your.
For each and every class.
Well, whatever I'm testing.
Or whatever you're changing.
Whatever I need to change. Sort of, I get enough coverage so I feel comfortable moving forward.
Right.
And it's generally just enough because, my evil twin wrote a lot of bad code before I started the refactoring.
Yeah. So and you see how that works for your idea. Take the code that you want to refactor, write some tests, see the code coverage, and when you've got all the lines covered, then you can pretty much go, okay, I see how it's supposed to be working, and then you can start trying to do the refactoring and see if you break things. Your evil twin reminded me. One of the problems people have with test-driven development or any kind of automated testing is, what if the test has a problem? And that's a valid fear, right? The problem is, there's a great quote, and I've forgotten who said it, but he said, if debugging is the process of taking bugs out of the code, programming is the process of putting them in, right? And we're humans, we make mistakes. I meant to do less than or equal to, and I just forgot the equal to, or some other issue like that. So it's a valid fear that, what if I make an error in the test code? Well, by stepping through bit by bit the three laws, right, write just enough of the test for it to fail, write just enough production code for it to pass, you're working with small bits and you're focused because I'm doing just this little piece. I'm doing this. It's not like, okay, I'm writing this whole thing and I've been going for a couple hours or whatever, right? No, you're focused on this one bit. And you notice if you've missed something. And if you don't notice something, when you go back and look at it, right, it's the then statement or the given statement says when the value is less than or equal to whatever, and you look at the code and goes, wait a minute, where's the less than or equal to? I just have a less than here. Okay, right. So you have safety nets with safety nets or something if you want to think of it that way. But it makes it easier to trust your test code because you know it was written well, because if it wasn't, you'd catch it. The other thing you can do is there's, what's it called? There's a tool out there that basically will take your source code and make changes to it. And I've forgotten the name of the thing now. Pardon? Fuzzing. Yeah, fuzzing tools, essentially. So it will go ahead and look at your source code and say, okay, this says if this is true, let's make that false. And then it runs your tests. And if your tests don't catch the fact that that mutant is, that change is in there, you know you've got a problem with your code. Right? So it'll tell you, hey, I made this change, I expected this to fail, but it didn't fail. So you know you've got a problem with your code. So you can run those kind of tests as well. And when it comes to code coverage, if you're doing this, right, if you're writing your test code like this and writing the code to make it pass, The only reason you have for writing a piece of code is that there's a test for it, which means you get close to 100% code coverage just by doing this kind of style of doing things, right? You don't have to try and like, oh, let me see if I can boost, write some tests for this or something. The code doesn't exist unless it has a reason, and the reason for it to exist is there was a failing test. So you're going to get high 90s or 100% test code coverage anyway, right? You don't have to spend extra time to go back there and fill in the places that might have been missed. So, okay. Anything else? No?
How do you feel about unit testing getters and setters?
That happens when I'm testing the rest of the code, right? If I'm testing a piece that does, I don't know, some calculation, right? I have to get the data from the database, it has to come into the object, and I'm manipulating things and I'm writing stuff back out. Well, if you run your code coverage, you'll see that the getters and setters were called, or those fields are never used, right? Yeah. Basic, well, or it could be that initially they were used, but they got dropped, right? We're not using those anymore because we don't care about that section. But here's the thing. If a getter fails, and there's no business logic in it, it's just getting the value, right? If that fails, how are you going to fix it? You can't, right? So is there value in testing it? Maybe. I did work, when I was working in Chicago, we had a new version of a C compiler come out from Microsoft. And the guys had a problem because they ran their code and it failed. There was a bug in it, they could tell. So they ran it with debugging turned on, but there was a problem with the compiler. When you turn debugging on, code passed fine. It didn't, no errors, right? And it's like, the next day we got what was called a flying update. It showed up in like express mail, and it was a flying update for the compiler, and that fixed it so that, okay, now the compiler and the debugging version give you the same code essentially, it's just got the other stuff in it, and so they were able to find the problem and fix it. But yeah, it's sometimes code is really weird, right? Ah, yes, sir. Oh, I'm sorry.
You had something plugged into the serial port on it. This is a long time ago. Then, reading the debug out, the Ethernet card would be connected to it and would run fine. The moment you unplugged the serial port, it would stop working because it was dependent on that process of writing to the serial port to use the networking card.
Yeah.
Yeah, that was terrible. That was telco days.
Question. I wanted to ask about, so there are a lot of companies that don't even do TDD, don't have specs. What do you do about those?
Well, if you don't have specs, how do you know what you're supposed to produce?
You tell me. Apply to the next one.
I mean,
I've worked with like different companies for like 10 years, and none of them have ever had specs or TDD or anything like that.
So
I've thought about maybe doing it on my own, maybe, but
yeah. Well, so you can do test-driven development on your own, and actually, there's a friend of mine who I haven't seen him around for a while, but he started with a new company, and he joined a team, and most of the developers were a lot younger than he was. And at the end of their first sprint, the boss came over and talked to him and said, I'm a little concerned because I noticed that compared to the other developers, you haven't produced nearly as much. And then it went to QA, and the results came back, and he came back and said, I was wrong. Because all of his stuff worked, and they came back with lots of bugs and problems that hadn't been caught. He was doing automated testing and doing it the clean way, and they were writing code the way they'd been taught. And that's what happens. I don't know of a class yet where when you go to college, they say, okay, here's how to write tests. Here's how to debug your code. Right? What they do is they teach you the basics. You do hello world, you do add some numbers, and play with strings and stuff. And it's all small, simple stuff that fits in your head. Right? It all makes sense. And then you play with bigger things, and then you go out and get a job, and now you've got stuff that doesn't fit in your head. and it's complicated, and it might be time critical as to when this happens versus this happens, right? You weren't taught how to do that stuff, how to test it, how to make sure it works. So how should you know? How would you know? Well, you have to dig into books and things like this, and right? But by breaking it down in small pieces, there's a book out now called Code That Fits in Your Head. It's a good book because it talks about how do you break things down so that you can understand what this does, even though it's very complex. Right? You just have to. The way that humans deal with complexity is we either split it up or we hide it. Right? We hide it behind another method and say, "Don't worry about that right now. It's handled." And then when you go in there, you deal with that by itself. Right? But if you're trying to do with three complex things, you can't do that. Right? You're going to have all sorts of issues. So you either split it up or you hide it and abstract it. It's the quote. It's like, "There's nothing that can't be fixed with another layer of abstraction, except performance." If you don't have any requirements, I've had to deal with this recently. If you don't have requirements and you have another person, like a QA person, come in, now you got a problem because I understand what you told me to do, but they heard something different, right? So when I turn over my code and it does what I understood it to do, they think it's supposed to do something different, and they say it's wrong, and then we got to go to you and say, well, which is right? Right? That's a waste of time and money. And if you've got a business that's doing that, they would do well to learn to actually the requirements are always in Jira tickets? Okay, okay, yeah. Well, you can do that, and then, so, once again, you can go back and do what I was showing you there with the specifications. Given this, when this happens, what should it do? And you can write that down and send it to them and say, okay, this is what I think is supposed to happen. Is that what you want? And they can say yes or no. And if they say no, I say, okay, well, what do you want? And eventually, you'll start getting traction, right? Because you're going to get stuff done quicker and more effectively than the people who are trying to go, well, I'm going to guess and try this, I'm going to try that, and they're, hopefully they will learn. If they don't, you've learned some better skills and you can go someplace else and use them there, right?
You also don't want to confuse the developer with a list of specs, especially if you're an architect. You're going to make out a set of Jira tickets so they can focus on each individual task that they're assigned. Because I have found that generally speaking, in large development environments, if you have people that are running around with specs, they're worried about things that don't apply to them. And so that
if it's something that you're not responsible for, then
exactly.
Yeah, definitely.
So that,
but if
what he's describing there, I think, is more common today. Is that you typically have an architect or a lead developer who's generating these stories in like an application like Jira, and that's where you would see that. It's probably why you don't actually see the whole list of specs. It's because a lot of it has absolutely nothing to do with what your particular task is.
Yeah.
And so that way the rest of the team is handling individual parts, and then you have one collector at the end who's actually making a single application out of it, especially in microservice-driven application development. So, I can see where he's saying that he doesn't see the specs, but that's what I do, because if my developers are worrying about things that have nothing to do, they're wasting their time.
But you make sure that the person who's responsible for something knows what the specs are for that thing.
Oh, yeah.
Right.
Well, I mean, but if it's a story, it should be like 3 things inside that ticket. It's got to be X, Y, and Z, right? Otherwise,
but I got the impression you were saying that you're not getting that.
Like what you described as the solution to TDD and its 3 laws is essentially like creating this living document based on like specs, like the specification library. And I don't see, it looks like you would have to have buy-in from most of your developers and the people at your company for this to be useful. Like you as an individual developer couldn't introduce this. Or
actually
you could try, but if nobody...
You can introduce it, and what they'll see is this one area is well understood. These other areas, not so much. Why? Because I've got a description and I've got code that shows how it actually works. As opposed to, well, here's a bunch of code, good luck.
I would put it as the world is messy and complicated. Life sucks, right? We are not computers, we are humans. What we do is we try to translate that messy and complicated world into code. And as much as you can, it's never going to be 100%. Nobody does 100% coverage. Almost nobody has 100% TDD, right? It's a lot simpler to do it with a stack than with an enterprise system with hundreds of microservices and things like that, right? So it's not 100%, right? But you get as much as you can whenever you can. And then you jump to a better company whenever you can. Until eventually it matches.
Yeah. So there's a company called ThoughtWorks. And for years, they have claimed that they are doing 100% code coverage. Now, I know some of the people who work at ThoughtWorks, and I am impressed with every one of them. I can also tell you that there are other companies that have 100% code coverage, but they don't have any asserts in their code. So yeah, it's run, and it all passes, but it doesn't actually mean anything. The folks at ThoughtWorks, if they're telling anyone that they're doing 100% code coverage, I have no doubt that they actually are. They're testing everything, and they're asserting everything. And there's a reason why they're expensive, because they do a good job, and you pay for that. For most companies, that level isn't necessary. We know that because they're way below 100% code coverage right now, right? Code coverage itself, it's nice, but it doesn't necessarily mean anything, But if the only reason you're writing code is because you've got a requirement, then you know that the time that you're spending is actually worthwhile in terms of meeting the business need. Now, maybe you're writing a game program, and so it just helps people waste their time or shows them ads or whatever. But professionally, you're doing the right thing, right? And at the end of the day, I think that's pretty much all you can hope for is that we're good at what we do, and we bring value to the people who are paying us to work for them. Okay. Anything else? We can stop recording. If you've got other questions, we can do things off and do it like that. So appreciate it. Thank you very much.